Welcome to my second video over surface area. In this video, we are going to go over pyramids and cones. So let's go over some information before we look at our formula. So starting off, we have our pyramids, where all faces except one are going to intersect at the vertex. Your base is going to be the face that does not intersect at the vertex. It's always going to be a polygon. Your lateral faces are going to be the faces that intersect at the vertex, and these are always going to be triangles. Your lateral edges are going to be the edges that have the same vertex as the endpoint. And your altitude is going to be a segment from the vertex so that it is perpendicular to the base. Then moving on, we have our regular pyramids. A regular pyramid is where the base is going to be a regular polygon, and the segment from the vertex to the center of the base is your altitude. All lateral faces are going to be congruent isosceles triangles, and your slant height is going to be the height of each lateral face. Moving into our circular cones. Obviously, your base is going to be a circle, and then a cone whose axis is also the altitude is called a right cone. An oblique cone is a cone where the axis is not perpendicular to the base. And so they are giving you an example here of a right cone, okay, showing that our height is going to be perpendicular to our base, in this sense, our radius. And then over here, you'll see that your axis is not your altitude, it is not perpendicular. It's kind of being slanted. And so we need to always look for our altitude to be perpendicular to our base. So just be mindful of that. All right, let's talk about our formula. So once again, we have our two formulas. We have our lateral and our total surface area. So lateral is everything but the bases, and that formula is 1/2 perimeter, remember it's of the base, times your L, which is your slant height. So that lowercase italicized L stands for slant height. Then moving into our surface area, you'll recall that surface area starts with your lateral area, so they're the same. And then we're just going to add the area of the base. So here, since we do not have the two bases like a prism, we're just going to add the area of the 1B. All right, so let's look at some practice problems down below. We have find the lateral area and surface area of the regular pyramid whose altitude is going to be 15 centimeters, So let me label my picture real quick. I'm just going to draw it to be perpendicular so that I know, and say that this right here is going to be 15 centimeters. They also tell me that the edge of the base is going to be 16 centimeters. Okay, so the edge of my base just going to be one of these sides here that is going to create my base. Now, keep in mind they did mention that this was going to be a regular pyramid. So here I'm going to start by highlighting my base, just because I always do. But that regular terms means that this is going to be a square, okay? So just keep that in mind. All right, so let's start off with our P. So our P for perimeter of the base is going to be that 16 times 4, since we have 4 sides that are congruent. And so that is how we are going to get that our P is 64. Then we have our L, our slant height that we're looking for. I do a little cursive L just so y'all can see the difference. And so here, that slant height would be along here, which I don't know that length. But what is going to happen is I am going to use Pythagorean theorem to find it. Okay, so here I've got that the altitude is 15 centimeters. The whole edge of my base is 16, but that altitude should go through the middle. And so I know that the base of my right triangle here is going to be 8 centimeters, half of that 16. So I'll use those as my A and my B in Pythagorean theorem to find my C, my slant height. So when I square, I get 225 plus 64. It's going to be equal to my C squared. I'm going to add them and take the square root. And so here, when I add them together, I'm going to get 289. So I've got the square root of 289 is equal to my C, which should just give me 17. So that means that my slant height here is going to be 17. Then for my capital B, area of the base, since we have that that square, we are going to just take 16 times 16 or square it to get 256 as my capital B. Plugging into my two formulas. So for my lateral, remember we're going to take that 1/2 of my perimeter, so 64, times my slant height of 17. So half of 64 times 17 should give you 544. And then this is going to be an answer, so I need my units, centimeters squared. Then finding my surface area, remember you just start off with your lateral area, so that 544, plus my B, so that 256. And when you add those two together, you should get 800. And we'll have our centimeters squared, units squared, since we have this as an answer. All right, now let's move into number 2. For number 2, we are asked to find the lateral area and surface area of the regular triangular pyramid. Okay, so I'm going to start off by highlighting my base. Okay, so we have our base here. And then we need to start by finding the perimeter. Okay, since once again it says regular, that means that all of these sides are going to be congruent. So I'm going to take 3 times the 12, my side length, and I'll get 36. Okay, then from there, we are going to find our slant height. So remember, your slant height is going to be the height of the lateral face. Okay, so here's our lateral face over here, or an example of one. And so the height of that is going to be this dashed line that they have drawn. So we need to figure out that length. Now they were very nice and they provided us with our lateral edge here to be 10. We notice that this full side here is going to be 12. They did mention that we would have isosceles triangles as our lateral faces. And so the altitude or the height drawn on an isosceles triangle is going to bisect it. So here I'm going to deal with 6. We have that 10, and this is going to create a right triangle that we can use Pythagorean theorem on to find that slant height. So we are going to use, we'll have our 6 squared plus B squared is going to be equal to 10 squared. So squaring everything, I'll get 36 plus b squared is equal to 100. When I subtract, and then I'm going to go ahead and square root, I'm going to get the square root of 64, which you know to be 8. So I'm going to have a slant height of 8. Then moving on to my area of my base. So this is a triangle. Remember, we have that 1/2 base times height. Or if you would like, you can also, and I'll write it down, use the formula for area of an equilateral triangle, which is your s squared root 3 over 4. Not many of my students tend to memorize this, so I'm going to go ahead and just plug into our 1/2 base times height, since a lot of my students are going to use that, but this is always there, and remember, your S stands for your side. All right, so dealing with the area of this triangle here, we would have our base, so 1/2 base, which would be 12, times my height. So I'm going to do just a little right triangle over here so we can kind of see what's happening. So remember, when we have an equilateral triangle, we draw that altitude for my height, it is going to bisect the side, so we get 6. We have that it's also 60-degree angles, and when you bisect that, you get left with a 30. So we have a 30, 60, 90. Okay, and that 6 that we found, that's going to be our S, and our altitude becomes our S root 3. And so that's where I'm going to get that my altitude is going to be 6 root 3. So half of 12 gives me 6. 6 times the 6 root 3 is going to give me 36 root 3. So now that we have that, we can plug in for our lateral. So we would have our 1/2, our perimeter, so 36, times our slant height of 8. And when you multiply all that together, you should get 144. Since this is an answer, I'm going to put units squared since they don't provide us with any. And then plugging into our surface area, remember it's just your lateral, so that 144 plus the area of the base, the 36 root 3, which, if you remember from our first video over surface area, we mentioned how since this has a radical in it and the other one did not have that square root of 3 as well, you can't combine anymore. So this would be my answer, and I'm going to put units squared on the end. Now, before I move into the next problem, I do want to mention just a common issue I do notice a lot. And so just to point that out, here in my lateral formula, you saw that I took 1/2 the perimeter times the slant height to get that 144. Now, keep in mind, this has already been halved. So when I plug it in down here, please do not take half of it again. You found your lateral. You've already taken half. Please do not half it again when you plug in to find your surface area. All right, now let's move into our third problem. For number 3, it says find the altitude of a regular square pyramid with a base edge of 12 centimeters and a lateral area of 240 centimeters squared. All right, I am not great at drawing when it comes to 3D, so I'm not going to try and attempt to draw this, but since I am finding the altitude, I know that it's going to be perpendicular. It's going to create a right triangle. So I am going to start by drawing a right triangle. I'm looking for that altitude. Okay. And we have a base edge. Okay. So base edge of 12 centimeters. Remember, that altitude should bisect your side. Should be only using half of that base edge. And so I'm going to use 6 here instead. And they give us a lateral area of 240. Okay, so in order for me to find my altitude, I would probably need to know my slant height, which I don't know. But let's keep in mind that that lateral area formula is going to be equal to 1/2 my perimeter times my slant height. I know my lateral is 240. I'm taking half of my perimeter, which I can find. Remember, your perimeter is the perimeter of the base, which they told us our base edge is going to be 12. So 4 times 12 is going to give me 48 for my perimeter. And then that's going to leave me with my slant height to solve for. So here, if we simplify, we get that 240 is going to be equal to 24 times my slant height. And when you divide, you'll be left with 10 for your slant height. And now I can find my altitude by using Pythagorean theorem. So to solve for it, I'm going to take that 6 squared plus b squared is going to be equal to 10 squared. When we square everything, we're going to get 36 plus b squared is equal to 100. And when I subtract and take the square root, I'll get b is equal to the square root of 64, which, if you remember up above, we already knew this to be 8. So my altitude here is going to be equal to 8 centimeters. Make sure you include your units. All right, so now let's go ahead and flip over and let's do some practice problems for our cones. All right, so for number 4, we are finding the lateral and surface area of a right circular cone at the right. So this one over here. So let's start off with our P. So our P is perimeter of the base. Remember here, you have a circle as your base. And so we're actually going to be finding circumference, which is 2 pi r, or pi times diameter. Since I have diameter, I'm going to use that. Then we need our slant height, which is going to be that 15 that you see. And then for the capital B area of the base, we'll need our radius. Okay, so my radius, remember, is going to be half of my diameter. So that 12 divided by 2 is going to give me 6. So I'll take 6 squared times pi, which will give me 36 pi. Now we can plug in for our lateral area, which is going to be that 1/2 our P, so 12 pi, times our slant height of 15. Half of 12 is going to give me 6 pi times 15, and I'll get 90 pi, and we'll have units squared for our answer. Okay, then moving into our surface area. Remember, once again, we're going to just take what we got for lateral, so that 90 pi, and add the area of the base, the 36 pi. So when you add those two together, you're going to get 126 pi. We'll have our units squared. All right, moving into our next problem, number 5. We have find the lateral and surface area of the right circular cone at the right. So once again, since this is a cone, we're going to have that my base is going to be the circle. So I'm going to highlight that. I can start off by finding my P for my circumference of that circle. I'm using pi times 2 times my radius of 5 to get 10 pi. Then we need our slant height. Okay, so once again, we need the slant height. That is going to be along the edge of the cone. It's not the perpendicular one. So we're going to use Pythagorean theorem to find this. We have our 5 squared plus our 12 squared is going to be equal to c squared. When you square everything, you'll get 25 plus 144 is equal to c squared. And so I'm going to take the square root and add those two together to get 169. It's equal to my c. And therefore, my slant height is going to be 13. Then finding my capital B, my area of the base, I will have pi radius squared, so 5 squared, to get 25 pi. Now I have everything I need. I'm going to plug in for my lateral. We've got that 1/2 my perimeter, so 10 pi, times my slant height of 13. So half of 10 is going to give me 5 pi times 13 will give me 65 pi, and we'll have our units squared. Okay, and then for my surface area, I'm going to take that 65 pi. I'm going to add to it that 25 pi I got for the area of the base. When you add those two together, you should get 90 pi units squared. All right, moving into the final problem for these notes. This one is going to be a two-parter. We have the plane region is revolved completely about the given line to sweep out a solid of revolution. Describe the solid, and then find its surface area in terms of pi. So we're going to start off easy with the about the x-axis. Okay, so I'm going to start by highlighting the line I'm going to rotate it about. And if you watched my last video, I mentioned that since we are rotating it, we are making a circle as our base. I'm going to try my best to kind of draw this out for you to see what's happening. Okay, and so I'm going to have that same shape over here on this side. And so you can see here that we are going to have a cone. So this is going to be a cone. And we can say with an R, a radius of, let's see, we've got 1, 2, 3. And then we'll have a height of 1, 2, 3, 4, 5. We won't necessarily need that, but it will help us in the end. So we said that our radius was 3, and then we're going to have a height equal to 5. Okay, so finding my P. We have our 2 pi r, so 3, to get 6 pi. Then for my slant height, this is why I wanted that height. It wasn't necessarily going to be my answer, but it's going to help me find my slant height. So remember here you have your height is perpendicular. So that's going to be 5. And then we have our radius of 3 here. So plugging into Pythagorean theorem, I'm going to have 5 squared plus 3 squared is equal to my c squared. When I square, I get 25 plus 9 is equal to that c squared. Taking the square root and adding them, I should get 34 is equal to my c. And so here we're going to have a slant height that is going to be equal to the square root of 34. Now moving into our b, we are going to have that pi and then our radius 3 squared. So we get 9 pi. All right, so I'm skipping over my slant height because I just need my surface area is what they asked for. So we've got our 1/2 of our p, so 6 pi, times my slant height of the square root of 34, plus my b, 9 pi. So half of that 6 is going to give me 3 pi times the square root of 34 plus we'll have that 9 pi. Since I cannot combine anymore, I'm going to just write my units squared at the end. Now, I just want to mention something. Personally, I would highly suggest you put the 3 pi in front of the square root, because if you put it after, it's not that it's wrong, but if you accidentally draw that square root out too far and it shows to be underneath, it's questionable. So like, for example, here you've got that 34, and maybe I just get sloppy with it and I go like this. That looks like that's going underneath, and that could cause an issue. You could lose some points. So play it safe and just put it in front so you don't have to question it. So I'm going to erase that. Now let's move into part B, which this one is going to be a little bit trickier. So I'm going to erase so that we can start fresh and see what's going to happen here. All right, so for this problem, we are going to be rotating about the y-axis. Okay, so right here. And so I am going to, since we are rotating about it, we're going to have that circle being formed. So I'm going to draw that out down here. It's not going to be perfect, but hopefully it'll just help you see visually what's going on. And then the same thing up here from this point. All right, so, oh, my bad. Let me erase that. I did not go out far enough. Should be the same distance, so 2, 4, 5. There we go. All right, so I'm going to connect them to draw out. I'm drawing the same picture that I see this triangle over here on this side. And so hopefully you're kind of seeing it, but it's going to be a cylinder with a nice cone-shaped hole in the middle. So I'm just going to say that it is a cylinder with a cone removed. All right, so we need to find the surface area for this. We're going to start off with our cylinder. And I'll kind of explain what I'm doing with it as I go along. But we're going to start with our cylinder since, you know, we have a big chunk of that. So starting with my P. Okay, so for my cylinder here, I'm going to have a radius of, we've got 1, 2, 3, 4, 5. And so I'm going to have 2 pi times 5 to give me 10 pi. Then I've got a height. So from circle to circle, we've got 1, 2, 3. And then finding my capital B, area of the base, we've got our pi radius, so 5 squared, to give me 25 pi. So they asked for surface area, so that's what I'm going to find. But, so plugging into it, we have our P, so 10 pi, times my H, my height, 3, plus, technically it should be 2B. But if you remember up above, I mentioned this is a cylinder with a cone removed. That means that up here, this is going to be a nice little hole in my cylinder, which means I really don't actually have 2 bases in it. I only have the one. So instead of adding 2B, I'm just going to add 1 base. So that's why I have that 25 pi and not 50 pi there. All right, so we've got 10 times 3 gives me 30 pi, plus 25 pi is going to give me 55 pi. Now let's talk about that cone. So this is where surface area is definitely a little more challenging than volume, because in volume, you would just subtract it, right? But with surface area, when I take that hole out, I'm still going to have a surface that is now exposed to the outside. And therefore, I'm actually going to be finding lateral area of that cone to add back in for my total surface area of this figure. So like I said, it can be a little confusing, but because you now have a new surface that is exposed to the outside, that is the lateral of the cone, we need to find the lateral of my cone to add in to figure out the total surface area of this figure. So we're going to start with our P, which it should be the same as the cylinder. So I'm just going to copy down my 10 pi here. Then we have our slant height that we're going to need, which I would like to mention the slant height for this one is the slant height we already found in part A. So that's why I'm not redoing it. It is that same square root of 34. And so now I can plug into my formula for lateral, which is that 1/2 my P, so 10 pi, times my slant height of the square root of 34. Okay, so solving that, we've got 1/2 of 10 gives me 5 pi, times that square root of 34. I cannot simplify. So that becomes my lateral area. And now, like I said, you're actually going to be adding these together. So for my SA, my total SA of this figure, my final answer, I'm going to take that 55 pi plus 5 pi root 34. And we are going to get that as my final answer. So I'm going to put my units squared on the end. And we are now finished with our day 2 lesson of surface area that deals with our cones and our pyramids.